That should be my recording just dialed in. Hi, who just joined?
This is Greg Trotter with Pathmaker Group.
Hi.
Hello.
Glad you could join us today. I heard somebody else just joined us.
Hey, Eddie, this is Bolly.
Hey, Bolly. Good to have you here today. Hello? Who just joined us?
Hi, this is Chandraji from ATEC.
Hi, good to have you here.
Hi.
Welcome. Who just joined?
Hi, this is Brian Goldsmith.
Hi, Brian.
Hello.
What's the sunrise going to look like today?
Oh, the sun has not risen yet.
No, I didn't think so. Not that far west.
No.
We'll just give people a few more moments to get on, and then we'll get started. This is being recorded today, so all of you know. And we'll make the recording available afterwards. The last one's already been YouTubed. Good morning. Who just joined us?
Hey, it's Angela.
Hi, Angela.
Hey, how are you?
Oh, doing fine, doing fine. Just chafing at the bit to get started.
Okay.
Good morning. Who just joined the
Good
call?
morning. Ray Rieski, how you doing?
Just fine, thank you. And you?
No complaints. No complaints at all.
You ready to look at creating custom components today?
Absolutely.
All right, we're going to go ahead and get started. Let me just share out my screen. And the topic today is going to be building custom components in TDI, specifically how to script these and debug them directly in the TDI development tool in the CE. And you can all see my screen now, I'm hoping.
Yes.
Okay. Thank you, Angela. So this page right here to our ISM library, here is a packet that you can download, and it contains a scripted connector for working with Twitter. We'll be taking a look at that later, as well as good documentation on how it was built. So I'm going to put that, first of all, in the chat. And choose all recipients. You guys should all have that now. But to begin with, we'll start off just a little bit more simply. There's also a YouTube video here, and I'll drop this into the chat as well, which, although it starts out with TDI, it then proceeds to 7. But the principles are all the same. So this video also shows you how to build a custom component using JavaScript. And I'm going to build the same component here. So you'll get a couple of copies of this video then available on YouTube. So let me just start by closing these tabs and then creating a new connector. So I've got my TDI CE up. I'm under Resources Connectors. I'm going to put this in my library so I can reuse it in assembly lines. I choose to create a new connector. Maybe I did that a bit quickly. For the sake of the video, I'll do it a little bit more slowly. And then in the search, I'm going to type script. And I can see I have a base template for a script connector, as well as a connector in my library that's based on the script connector. So we'll choose this one. I'm going to call it my file scan. And then I'll set it to iterator mode. It doesn't really matter what mode the connector is in while it's in my library. The mode is only important when a connector is in an assembly line, because that tells the assembly line how to power that connector. And then I'll hit finish. Now this is a scripted component which has some built-in functionality. There's already a little script snippet in there which shows me which methods are available for a script connector. And it'll work out of the box. So I can hit the connect button and hit next. And as you can see, it's a simple counter. It's just counting up every time I press next. And finally, when I get to it's going to count to 100. So I'm not going to do that. But you'll notice that it has all the tabs, all the functionality that a connector gets. And that's because a connector is really in two parts. We have our assembly line connector, which is this wrapper we're looking at that provides our maps, provides the hook flows, the ability to turn on delta detection for iterators. Connection is going to be our configuration stream. Connection error handling, which now also in TDI 7.1.1 allows us to do failover, which means we can actually point to another connector in our library, which is set up to handle failover if this connector loses connections. And then finally, pool, because we can also, for our library connectors, we set up a pool of connectors, which then are shared by, for example, multiple assembly lines. Now, if I go to the connection tab, you'll see there is no real form here, as we see other connectors. There are some stuff in the advanced. But what I get up here in the general area is the edit script button. And if I press this, it opens a script editor, and we can take a look at this script. Now, whenever a connector is initialized, or a script connector is initialized, the script is evaluated. So all of these functions then are registered and are available, and anything that's outside the function definitions is going to be executed. So in this connector here, it's defining a counter, setting it to 0. Now then, depending on which mode you want this connector to operate in, you have to implement one or more of these methods. For iterator mode, we have two methods. We have the select entries and the get next entry. In our select entries, that's where we want to get our result set. Or with a file connector, we move the byte pointer back to the start of the file. In our case here, we set the counter to 0 again. So every time it's reselected, the counter goes back to 0. Then for every cycle, once the assembly line is initialized and begins to run, it's the get next entry which is called. And in this case, it checks to see if the counter is greater than 100. If it is, it sets status, the result status to 0, which tells the assembly line connector wrapper that has this interface that that's the end of the data. And we then move on to the end of data hook and all that functionality which is built into the assembly line. Otherwise, we take entry. Entry is going to be the con object, which is passed back to that connector, assembly line connector from this interface. It's called entry here in our script. So that's already defined for us. We don't have to create one. We just simply set an attribute called counter to the counter. And this is the TDI 6 way of doing things. In TDI 7, I can simply say counter equals counter. So I can define new attributes this way. And then counter is initialized. And if I were to set this thing down to, let's say, 5, I can immediately test by going here to my input or output map, closing, and then reinitializing the connector. And then we start stepping through it. And once I get to 5, we then have reached the end of the data. Now, this is a very trivial connector script, so I'm going to make one that's a little bit less trivial. Instead of a counter, what I'm going to have here is I'm going to create a few variables. These are going to be globally available in my script. Now, it's important to note also that a scripted component, the interface script that we've written, doesn't live in the same scripting context as the assembly line itself. So inside here in my connector script, I don't have access to everything that I define and set up and are using in my assembly line. The way we talk through the assembly line is by passing stuff back and forth through this entry object. We put attributes into the bucket, we can get stuff back. We can also have parameters set for the connector, but we'll look at that in just a moment. So I'm going to create a file. I'm going to create a list, which we'll see what that is in just a moment, and a file index. So, and I'm also going to create a new method, which isn't listed here, which is initialize. If there is an initialize method, that is called at the point of initialization of the assembly line. And typically what happens in an initialize method for a connector is that any parameters that have been set in the forms are read from that form and then stored, let's say, in local variables of the connector. And then it establishes a connection to whatever target we're going to be talking to. So I'm also going to have a file path variable. And I'm going to set that equal to cemp. Now this won't work because this is a quoted string, the backslash is going to be an escape character on the P that'll be a tab. So I either need to use 2 backslashes, or since this is all pure Java in TDI, I can just use a /, and then it'll work on Windows and Unix. So in my initialize, what I'm going to do is I'm going to say that file equals new Java IO.file path. This is a standard Java object or Java class. I'm going to instantiate a new one. Taking a look here at the Java docs, which I've brought up here, and then going up to the constructors, I can see that I've got a constructor where I can just pass in the path to a file that I want to open. And a file is really an object on disk. It could be a file or a directory. Once I have a file, I have a method down here to see whether or not that file exists. So I can call the exists method, and it'll return true or false. And then furthermore, I can query the file to see whether or not it's a directory or a file, if it's hidden, that sort of thing. And finally, I have a method called list, which returns an array of strings that name the files and directories in that folder. So if it is a directory that I'm pointing my file path to, I can then list the files that are below it, and that's what this connector is going to do. Now, as with all Java things, Java libraries, you have access to deal with these directly in your scripts. We'll be looking at the Twitter connector in just a moment, which uses the Twitter for J library that's available. So I've got my file connector. If not file exists, then I'm going to throw an exception, file, not file or directory. My typing can just stabilize.
Hey, Eddie, I was wondering if I could ask a question really quickly.
Absolutely. Please, and to everybody, just stop me at any time. This is not a recording.
So for the file path, you're using C:/temp. Can you use a relative path, and if so, is that going to use the solution directory as kind of the route to the relative path?
That's a very good question. And you're absolutely right. One of the first things that the CE and the server does when you execute the IBM DITK or IBM DISRV command is it changes the working directory to the solution directory. So all relative paths will be off the solution directory. So if I had just called this temp, then it would look for temp under my solution directory. So, going back here, was that a good enough answer?
Yes, that's perfect. Thanks.
Okay. So if the file doesn't exist, I'm going to throw an error, and then it'll end up in the hook flows. I can deal with that in my assembly line connector in my iterator error or my default on error hook. And then we're going to say if file is directory, then our list is going to be equal to file.list, and we'll call that list method, which returns an array of file names. Else, list will equal to null, and it won't be able to return anything. Then our select entries, we set our file index to 0. All right, let's scroll a bit further down, and then I get to my get next entry. So in this case, I first want to check to say if this equals null. That means I'm pointing at a file or I haven't initialized yet. Or file index is greater than or equal to list.length. Then we set status to 0. And this set message is not necessary anymore. But I set the status to 0 and I return, which then tells the connector wrapper itself I've reached the end of data. Otherwise, I'm going to set a variable called file equal to list file index. And then I'm going to increment my file index. So to test this, I'll go up to my input map. I'll close, reinitialize, and reevaluate my script. And it kept the previous theme items. I'm going to remove that. But now I'm reading the files that are found in my temp folder. And of course, I could go a little bit further. I could grab the file, get the last modified date, and make that also a return attribute. And there is a file scan connector which is available on the TDI-users.org site, called the file scan connector, which does just that. And you can tell that you want the files returned sorted, let's say ascending or descending based on last modified date. So you can then be scanning a directory, and it also is able to search recursively, because if I'm pointing at a directory, or if one of the files in the list is a directory, I could then search it too. But this is our little connector. What I'd like to do now is instead of having to hard code or force the user to go in here and change this code, I would much rather be able to set a parameter. So that way in my initialize here, I could do something like file path equals connector.getParam file path and make a parameter with an internal name of file path and be able to have that settable by the user. Let me just save this and then close my file scan. And then I'm going to open my connector again, but this time I'm going to open it with the forms editor. And yes, I'll take the default. And I'm going to call this my file scan connector. I can load scripts in this as well, so I can actually make a form that reconfigures itself and changes depending on what values and what buttons are pressed. It's giving me two sections, a general and an advanced section. I'm going to leave the advanced section. Actually, I'm going to go ahead and remove the advanced section, I think. And in the general section, I have one of these built-in fields. The ones that start with $global are built-in fields that are given you, that are used in a lot of our standard connectors that you can also get access to. And this one is that edit the script button. So I'll just leave that in so I can debug this afterwards. And there's a couple of fields already defined. I'm going to leave them in. I'm not using them. I could remove them if I wanted to. But now I want to add my own file path parameter. Over here, we'll say that this is going to be, we'll call it path, will be the label. We can put a tooltip here, path to the folder, the connector will list. And I can choose the type, and there's a bunch of other things I can do with this, but this is what I want for this parameter. And then I need to add this to my general section. So I'll just press the add field. My own defined parameters show up at the top, so there's my file path. And I'm going to move that up. You'll notice if I wanted to be able to allow people to put in comments, let's see, what was that called again? User comment. So I can add that one as well. And I'm going to move that one just below the file path. So now to test this, I'm going to test form button. This is what the form is going to look like with my tooltip. Okay, we're happy with this. I'll save it, close it, and then open my connector, this time with the connector editor again. And now when I go to the connection tab, I have a path. So let's say I'm going to go to a relative directory. And let me just open up a file browser to my solution directory. And let me find a folder that doesn't have too much stuff in it. Okay, there's one file in the DLA folder. So if I just put DLA here, go to my input map, press connect, and next. There's the one file that it finds. And then it's empty. Now, you'll notice that every time I press the connect button, it comes up with counter here. And that's because this default script also implements the query schema. If you scroll down here, you'll see that we've got the method that we need for add-only mode, for delete, for lookup, which is also necessary for update and delete mode. Because if you know the hook flows, you know that these modes cause the connector to do a lookup first. And then finally, we have the query schema. And the way this is done is a new entry is created. E equals new IBM, IBM DI entry. We could also say system.new entry. we have a bunch of creation methods or factory methods also in the system object. And then we add a couple of values. One is going to be name, so this should be file instead. And this is of type string because it's just the name of the file. And then we add that to the list. If we wanted to add another attribute or another attribute to our schema, we'd do another new entry. We'd add a couple of attributes, and we'd add that to the list. And finally, we set status to 1, and that tells the connector that this is now the schema is now returned. So now, if we remove everything from our the schema area, we close this, and we connect. Now it shows up with file. So, any questions on what I've done so far? Does this look reasonably straightforward? All right. Now, one of the cool things about the TDI 711, many cool things about it, is that you can debug directly into the scripts of your connector. So I'm going to make an assembly line called test file scan. And one of the things I do in that YouTube video is I build my scripts as separate script objects in an assembly line so I can step through the script. But as of 711, I can now, the debugger will now step into scripted components for me automatically. So I'll take my file scan connector, I'll put it up here. We can see it's inherited, and I'm going to change the parameter here from DLA back to C:\M. So I get a few more files. And then I'll add a dump entry. So now when I start the debugger, let me just make this full screen, and I step into, first of all, it now steps into all the points, the waypoints in the hook flow where there could be scripts. My assembly line prologue before initialize is not defined, but it shows me I'm at this point. If I step into again, I end up in the connector. And now the connector is being evaluated. So now it defines these plus all of the functions. And the initialize. So now I'm stepping through my initialize. So the first thing I do is I'm going to read file path from the connector's parameter. And you'll notice, if any of you have done this before, you can always click on the name of a parameter or the little question mark out to the right of a parameter to see what the internal name is. And that's useful if you want to set that parameter using script. If I click on this, it brings up the parameter dialog, and it tells me what the internal name is, and that's the name that I gave it. And that means that this variable should now have that value. If we take a look here, and I paste this in, when I press enter, that line's evaluated, and it gives me the value that's in that variable right now. I'm going to step past that. Now I've stepped past the file equals, so now I've got a file object. And I can actually use all the methods from the debugger by just typing snippets of JavaScript in this JavaScript command line and pressing enter. And this is how I play with new libraries. I'll instantiate something and start calling methods until I can figure out how to use this library. And if I do something that's incorrect, it doesn't affect my assembly line. I get the exception displayed here, but it doesn't cause any difficulties for the assembly line that's running. It's simply caught by the debugger and displayed. So if we step through this, I'll need to step into an if statement, because if statements, if I do a step over, it steps over if statements and for statements and while statements. But the file exists. If it is a directory, then it'll do the list. And now I'm in the before selection. So now I'm finished with initialization, and now I'm in the hook of the connector before selection, and then it's going to call my select entries. And in this case, I set the file index to 0. And I can keep stepping through this until we're done with initialization. And the initialization dance will move from connector to connector down the assembly line until they're all set up and ready for the cycling to begin. Now we're back in the assembly lines, prologue after initialize, and the next hook of the assembly line is the start of cycle. So now we're on the on start of cycle, and now I'm in my first connector. So if I step into this, we'll get to the before execute. If you haven't played that much with hooks, I really suggest that you start taking a look at it because you see exactly what's going to happen from the top down. This is the data flow. This is the cycle hooks. I've got before and execute. I could have overridden the get next, but I haven't, so it's going to skip this. I've got the before get next, then the get next operation is called, so my get next entry method will be, we can step into that, and then the after get next. This is what we'll be seeing. So before execute of my connector, before get next, and then we're in the script. This makes it very simple to very quickly build new components. And the same is true for your parsers or your function components. So now entry, which is of type entry, the TDI entry, which means I can do entry.toXML and get an XML representation. Or I can do entry.toJSON and get a JSON representation. Or just do a task.log or dump entry and print out the entry. You'll notice I get the message from the debugger in the middle of this as well. But anything I can do in my assembly line, I can also do from here. Once we step past this, we're in the after get next, then in the success hooks, and finally we're down in the dump work entry. If I just let this run now, and then bring this up in a full screen, we can see that this is that nothing is being dumped in every one of these dumps. And can anybody guess what I forgot to do? This first dump worked because I was dumping the entry. This is from our debug.
The input map, you didn't set that.
Absolutely. I forgot to put the input map. So my connector interface is actually reading stuff into its local con bucket, which is called the entry variable, referenced by the entry variable in my script. But I forgot to mention to the connector that I wanted to bring these in. So I'll just map everything in. And now if I run it in console, we will get some output. These are the various files that were there. So this is my connector. And now we can take a look at the Twitter connector. The Twitter connector is a little bit more complex. And this is the document that you'll get if you download the packet from the zip file from the ISM library. And it talks about the Java library you have to use and a little bit about the REST API it's going to be using, because it's using OAuth to authenticate and authorize access. And then it's using REST calls with JSON payloads to send information to post tweets as well as to read the tweets that are there. And it talks about how to set up the form and really step-by-step how Rita built this component. So I recommend that you grab this. If we take a look here at its script, we see she's built a form with all these parameters. These all have internal names. And the internal name can have a space in it because you say get param quote, and you can put whatever you want in the quotes. If we take a look at the script, we can see that she's also maintaining the count, so she'll be getting some sort of a list back. Here's the initialize. It gets the various parameters from the form, and then it performs the OAuth authentication, sets up an instance of the Twitter API object she'll be using to make the calls. then in the select entries, there's a single call twitter.getUserTimeline. So the JSON call, the JSON work is being done for her. The Java library is handling this stuff for her. And then she sets the entry count to 0, and then down here in the get next entry, she's returning a $row number, which is the count, $number of rows, which is the length, and then user screen name, tweet, and date of creation. Those are the 3 attributes that she's setting based on this JSON return. Oops. Didn't mean for that to happen. So if we take a look at the select entries, what returns here is going to be, I think it's a JSON object, which contains the various properties that she's going to be accessing. So when she says here that status equals entries get entry count, so maybe not, I think it's an object, and maybe a Java object instead. So it gives her something that she can do a get on. And then she can get the user screen name, the status get text, and the status get created at. Increment stat sets result status to 1. So if we want to test this, let's just first go to the there we go. No. Twitter.com. So I've got a Twitter ID of TDI here. If we look at the 3 tweets that are there, there's one called testing, and then there's a couple of exceptions, which I'll show you how I created. Did those from another assembly line. So there are 3 tweets that I should be able to read. That means if we open up just not save this, if we open up the read tweets, we have our Twitter connector in iterator mode, mapping everything in. I have disabled the if choose tweet, because what she has in this example is if you choose @TDI account is found in the tweet, then it's going to send an email to somebody. So you could actually have an assembly line which is listening to tweets, and certain tweets it's going to mail out to make sure they show up in people's inboxes as well. But I'm just dumping the work entry out. I'm not actually dumping it. I'm printing out date of creation, then the user screen name, and then tweet itself. And I can run this. And those are the 3 tweets that we just saw. And I can debug and step through this, just like we did with the simple connector, the file scan connector that I just showed you. So during development, that's what you do. You're stepping through it and making sure that you've got all the calls in the right place, that you're interpreting the data correctly. If we wanted to know what kind of object it actually returned, we could debug this, step into our initialize. So let me just double click here, scroll down to my initialize method. And what I want to do is find out, my select entries. That's what I want. I want to know what object this is that I get back here. So I'm going to just toggle a breakpoint at this spot here in the script, and then hit the continue button. So now it'll continue to run until I get to the select entries. Now it's going to call this. So we'll just step past that. And now we have an entries. And if I do a .get class, this is a internal JSON response list implementation. So this is part of the Twitter for J. We could, of course, just use HTTP component and done the JSON calls ourselves, but this library makes things a lot simpler. Cool little thing here. If I wanted to just store the class, I want to say C equals, I create a new script variable called C, which is actually now available in the assembly line, although the assembly line is not going to make use of it. But now I've got the class. And then I could say I want the methods equals C.getMethods. and that returned a list or an array of methods. And now I can do a one-liner like for m in methods, ask log message m, and really just kind of explore what methods are available in that class. So these are the public methods that I'm able to access in that class. And there's been a couple of times when I've been handed a jar or a library, and I could, of course, decompile it and go look at it. I just wanted a list of methods to be able to try stuff out in the debugger, so I just did this and got my list, and then found the ones that I thought looked like they were probable. All right, so we can continue stepping through this, but it's going to work just like it did with the other ones. So we're going to get those 3 tweets printed out here in our log. On the flip side, to create the tweets, she's put in this tweet notify. So here, we're reading a CSV file, which just contains 3 lines. And that CSV file is also something you get in the zip file. And then she chooses the status to see whether it contains error. And if it does, she calls the Twitter connector in add-only mode and writes the Twitter text, because that's the field that you have to write. That's the schema that you need to, or the output attribute. Now, if I run this, I'm going to get an error, because these tweets are already there. But I get back an error that explains that. Request is understood, but it's been refused. And if we open up that error, it says status is a duplicate. So if we wanted to push these through regardless, we could add something to each one of these messages. When we call it, we could change the assignment and say plus new, and just add to it. If I run this now, it was able to send 2 of these messages, because our branch was true twice and false once, which means the connector was only run twice. And if we now go to our account and take a look at tweets, let's see, I probably have to refresh this page. And we now have the ones with new message as well. And that's really, in a nutshell, how you do this. How you build your own custom components. And anything you can do in Java, you can do from TDI. You have all the access to all the libraries and the same kind of approach. And I've taken Java connectors and converted them to JavaScript, because, of course, all the actual mechanisms you're working with when you're building an assembly line or building a component is with JavaScript instead. But all you're doing is manipulating Java objects. Any questions about what I've been doing here? Okay, well, we've still got time left, so I'm going to go ahead and open up for general questions. If you guys have stuff that you're wondering about, or you're working with, you have concerns, or you'd just like to see.
I did have one question back when you were in the debug mode.
Yes.
Were you able to, I noticed you had to type those variables into the line every time to get them to show up down in the output window. Is there a way to add those to a watch list or something so you don't have to type the variable every time?
Very good question. Okay, I'll make that full screen again. We'll start the debugger. There is also a YouTube video on the debugger. So it'll talk about some of these same things. But just looking at the debugger here, over on the right-hand side, I've got a watch list. Here in the middle, another thing is that when you first start the debugger, you're very likely going to start up in the data stepper the first time until you tell TDI that you want the full debugger. then it remembers to put you in the full debugger instead. But this is going to be the con entry for each of the connectors. So whatever's mapped in, whatever's read in before the input map will show up here for my iterator. For this function component, whatever I map out to it will show up here. If it was an add connector, it would also be the con entry from the output map. Then on the right-hand side, I have my watch list. Work and con are by default. All the global script variables are shown here. So let me just show you an example. If I do a step, and this list is only updated every time I step. So if we start, as soon as I press the step into, we have sent this assembly line description, the XML, to the server. It's built this stuff in memory, and it started to run it. So now I have a scripting environment. So now if I were to say I equals 42 and press enter, I've created a variable called I. If I step again, let me just close this, we can see now, and there's a lot of stuff in the global variable that's been created, including my, where did it go? Oh, no, we're inside, we're now inside the context of the script component. So I'm going to have to keep stepping until we get out of that. See, we've actually switched between the scripted context of the assembly line, and what I'm going to do is just simply right-click there and say, run and break in this component. One more time. This time I'm going to step over. That steps over initialization. We're now in the footer connector. Now I'm going to say I equals 42. One more time. Nothing up my sleeve. I've got no I defined here. I'm going to step over. So we've now moved down to our dump script over here. And now we see I is in the watch list. So these are just showing you all the globally available variables. You see the stuff that TDI gives you. It gives you the connectors and the branches, and everything that's defined as a component in the assembly line also becomes a variable. Here's the main object, which is the RS class, which gives us access to the TDI server itself. We have system, which is the TDI user functions, which is that library of very convenient methods for doing all kinds of stuff like creating entries or doing base 64 encoding or sending off emails. System gives you a lot of functionality. It's a good page to go take a look at in the Java docs. And we have task, which is the assembly line itself. And then below that, we have our watch list. So here, I can add wherever I want. I can even add a JavaScript line. I could say work.getString, and what was the name of one of these variables? One of these attributes? The tweet. So this is a line of JavaScript that I want in my watch list. I could also have I++ in my watch list. Now my watch list contains these things, and every time I step now, they're updated. You'll notice the I++ is updating my I, and this one's now showing tweet as it's in the work entry. Every time I step, it's updated again. So that's the watch list.
How about the actual variables in that connector? Can they be added there too?
Yes. They won't be visible when I'm outside. So we had an entry count. We go back to our connector. I've closed that. Just bring this up so we can look in the script. So we have an entry count, for example. I'm going to copy this and then go back to our debugger and add that to the watch list. Now, in this scope, didn't hit it right. Insert, and then OK. So at this point, it's not found. There's an exception. As soon as I step into the script, all of a sudden entry count is found, and I is not found anymore because that was defined in the scripting context of the assembly line. And there is no work in the script context of the connector interface either. So yes, we can define watch list and as we're stepping in and out of a test assembly line. Good questions. Let's hear the next one.
Eddie, so previously, and obviously even now, if you wanted to create your own custom connector, you could either build out your own jar file and add it to the TDI installation under jars and all of that, or you could use the config editor to build it out. If discussing these options with customers who are looking at building out a new custom connector, it seems to me that they can really do it all through the config editor. Is there any benefit you can see from your side for not doing it from the config editor?
I would say that comes down to the people who are building it. I mean, I'm very comfortable with JavaScript, and with the debugger, I feel like I can really interactively build, test, and refine what I'm working on. But if a team is very, very comfortable with Java, they might prefer to go that path because they have assets and resources for Java development, and it's fully documented how you do this using Java as well. You can still go into the connector once you bring it into an assembly line, and you can define the form for it. But that will only be for that copy of the connector. I can take a standard connector. Let me just show you that as well. So we'll just grab JDBC. Now I have a JDBC connector here, and I can open that in the forms editor, and I can say that this instance of the JDBC connector is not going to have some of these parameters. So let's say I don't want them to be able to choose the password. I just remove the field. And now in the test form, I've got the username, but I don't have the password field anymore. But this is only going to be in this .connector file, which is under my project, under the resources, in my workspace. This is not going to be in the jar itself. In the jar itself, you have a TDI XML where you define this form. So what you can do is build a form in the CE and then grab that XML snippet and put that into the TDI XML that has to be in the jar file.
Okay, and along those lines, with a jar file being recognized by TDI, it's obviously going to be accessible by all of the different projects that you open up through the config editor,
yes.
as opposed to this where you're setting it in the resources connector so that any assembly line in that project can use it. What do you recommend as the best way, though, if you wanted to share, let's say, the file scan or the Twitter connector, if you wanted to share those to other projects?
Okay.
Well,
if I've got a connector that I'm happy with, what I can do is right-click and publish it. And when I publish it, I create a package. I just give it a name. The package ID is just the name. And I can put some information about version and author and stuff. And this creates a package file which I can drop into my install folder packages or in solution directory. And then it's available like any other connector. Then it will show up in all my projects. Otherwise, what I'd have to do, you're absolutely right, is to take this Twitter connector file, which is in my TDI solution directory. It's under my workspace, and I've got multiple workspaces because I have multiple TDI versions installed, and I don't want to stamp a TDI 7 project with TDI 7.1.1 because then I can't open TDI 7.1 anymore. But underneath But workspace 711, if we look for TDI for Twitter, that's the project folder itself, Eclipse project. And my machine's a little bit slow right now. Then I've got my resources, connectors, and if I wanted to send you this, all I need to send you is this file. Because this is the XML snippet that's necessary to define that connector in somebody's library. I could drop it into the resources connectors of another, or just drag it into my, if I'd gotten this from you, I can just take this and drag it into my project. My keyboard's not working right now. Just drag it into my project, and it shows up under connectors. But yes, if I publish it instead, oh, that's why. If I publish it instead, then I can just put it in packages, and it's available in all my projects. Now, one thing I didn't mention was that I'm using the Twitter for J library. So what I have done, let me go back to my TDI solution directory. And in my solution properties file, I have, now you can always copy jar files into the install folder and put them under jars or under the JVM external, whatever. But if you put it under the jars folder, a subfolder there, it'll also be available. But I don't like to mix my libraries with what's standard with TDI. I like to just keep my TDI installed pristine as possible, and this is the stuff that I need to back up. All the stuff that's under my TDI solution directory. And here I've said that I'm using the property, the user jars property, to say that there's a relative path to a custom jars folder, which means it's going to be found in my solution directory. And this is where I put all my my custom libraries. So if we scroll back up in my solution directory here, we'll find my custom jars folder. And under custom jars, I've got a bunch of subfolders for different things that I'm working with. And any file that is zip or jar is going to be scanned, and it'll be available. So here are my Twitter libraries. And for this one, I only actually needed the core. I just copied the entire zip file that I was able to download, get a hold of. So that's how I manage my custom jar files and custom libraries. So drivers for different databases, license files, and whatever, I put them here. Build subfolders, and then I've only got one area that I have to keep a backup of. If I install a new TDI or something happens to that, I have to refresh that copy. Everything still works because I don't have to remember to copy jar files into that folder again. Good question. All good questions. Anything else? Sounds like some people are dropping off. We're getting towards the end here of our scheduled call, but this is really up to us how long we want to keep going.
Hello?
Okay. Yes, hi.
We spoke yesterday about this with multi-value attributes.
Yes.
Eller.
Yes. Okay. Let's just do a quick chat on that as well, because what Helena's talking about is that she has a situation where she was synchronizing groups, members of groups, and I think she was doing it to Active Directory. But regardless, what that means is that you end up having an attribute which has multiple values, the member attribute of a group entry. And what she was trying to do was list for every person she wanted to add to that group. She simply added, or she created an attribute with the value of that person, that URL to that person, and then she did an update. And what she was seeing was that only that one member was visible in the directory after the call. And this really brings us over to a discussion of TDI's delta or change detection features. And there's a good video that Johan's rolled on YouTube about this. It shows you how you can just get up and play with it very quickly. I'm going to create an assembly line. Let me just close all these things.
So we'll have probably a session on delta and change detection and so on later. So we're not going to spend too much time today. We probably want to close off the recording as well so that we can upload this. But certainly it's valid to spend a few minutes on helping out now as well.
Okay. So we're just going to call this 0_test delta. I'm going to add a form entry connector, which is one of my favorite connectors. And the form entry just lets me put stuff in here and then parse it with a parser. So it's already got some stuff in the simple format, and it has the simple parser already attached. So I should be able to read two entries, John and Jane. And then I'm going to add a dump entry. And when I run this, those of you who have seen entry dumps, notice that you get this operation in addition to any attributes. Now, I forgot actually to put the attributes in. Let me just do that again. I keep forgetting my input map. All right, and we'll run it again. So we end up with an operation generic, and then we have this parentheses replace for each one of the attributes. And that's because an entry, its attributes and the values the attributes are holding always have a change or a delta operation code attached. When you're just reading data and you're not using one of the change detection mechanisms, the entry is going to be tagged as generic and the attributes as replace. So what she was doing was reading in these new members, creating a new attribute, which by default is replace, adding one value, and then telling update to write that to Active Directory. And of course, update follows the operation codes and says, well, this member attribute is replace, so I'll replace what's already there with what this contains as far as values. So just to make a long story short, what I had her do before she actually did the write, and I don't have a connector doing write, but I'll just pretend like this is the before modify that she was writing to, and she had a member equals system new attribute member, and then member.add value, and we'll just say Eddie. And then what she has to do is make sure that the entry is tagged as modify, which tells the update mode that it has to look at the attribute tags. So we'll start by saying con.member equals member, con.set operation is modify. So now it'll look at the attributes themselves. Con.member.set operation, modify. And that tells update mode to look at the values, because the values will be tagged as add or delete. And then we can say con.member.set value operation. And we only have one value. We only add one value here, and that was Eddie. And that will be index 0. And that one's going to be add. So by just doing this first, when she then got to the update, it knew to only add that value to what was already there. And we can talk about this again on another call when we start talking about, or we're looking at change detection at TDI. Any other questions, or is it time to wind this down? All right, well, then I'm going to thank everybody for showing up today. I hope that you guys found it interesting. And again, if you've got questions, that's what our forum is for. Just go to the Google group and post your questions there. If something is very urgent, then drop us a line. And I'll close up this recording, and we'll get that YouTube as quickly as possible.